Welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the ESE 2021 Prelims solutions of the electrical engineering in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. So now we are going to solve the 21 question. See the question here. If P1 and P2 be the iron and copper losses of a transformer and full load, then what is the ratio of the P1 and P2 such that the maximum efficiency occurs at the 75% of the full load? So in this question they are given that P1 and P2 are the iron loss and the copper loss at the full load. So here at the 75% of the full load, you have to find what is the ratio of the P1 and P2. So what is the ratio of P1 and P2 such that maximum efficiency occurs at 75% of the full load? Means the maximum efficiency is going to occur at the 75% of the full load. At this condition we have to find what is the ratio of the P1 by P2 we need to figure out. So what are the four options? Option D 9/16 is the correct solution of this question. So let's solve this numerical. So basically at the maximum efficiency in a transformer, the condition is the constant loss is equal to the variable loss. So in the transformer the constant loss is the iron loss and the variable loss is the copper loss, because the copper loss is going to depend upon the load. So therefore here, so the copper loss we can write, which is I square times the RO1, means the effective resistance when referred to the primary, or you can go for the secondary also, means you can write RO2, means the effective resistance of both the primary winding and the secondary winding referred to secondary or primary, you can take any value. So therefore here the current in the transformer at any time, means at any load, is a fraction of the full load current. So therefore here the current in the transformer windings is equal to fraction of the total current, which is the full load current. So therefore here in place of I am going to replace XIFL or XI full load whole square. So therefore I am going to get here X square I full load square RO0. So this is called as the full load copper loss, because at the full load the amount of current is IFL. So therefore here this is the amount of full load copper loss. So therefore Pi iron loss is equal to X square times the copper loss at full load. So in the question they are given that at X is, means that at the 75% of the full load the maximum efficiency is going to occur. So therefore X is equal to 0.75. So in place of X I am going to substitute here. They are also given that the iron loss is equal to P1 and the full load copper loss is P2. So therefore iron loss by full load copper loss is equal to iron loss is P1 and this is P2. So therefore here this is X square. X square is the only thing which is going to remain. So in place of X I am going to substitute here 0.75 whole square. So we can write it is 75 by 100 whole square. So after doing the simplification, finally we are going to get 9/16. So therefore here the ratio of the iron loss by full load copper loss is equal to 9/16 at 75% of the full load. So now we are going to solve the 22nd question. See the question here. A sinusoidal flux 0.02 Weber links with 55 turns of a transformer secondary. So what is the RMS value of the induced EMF in the secondary if the supply frequency is 50 Hz? So in this question they are given the flux which is 0.02 Weber. It is going to link with the 55 turns which are present in the secondary winding of a transformer. So therefore here what is the RMS value of the induced EMF in the secondary? We need to figure out if the supply frequency is 50 Hz. So what are the four options? Option A 244.2 volt is the correct solution of this question. So let's solve this numerical. So basically this is a transformer with the primary winding turns of N1 and the secondary winding of turns N2, and the flux in the core is 5. So therefore here in the question they are given that the number of turns of the secondary, which is N2, is equal to 55, and the flux which is going to link the secondary winding is maximum flux is 0.02 Weber and the frequency of this flux is 50 Hz. So we have to find what is the EMF which is going to induced in this secondary. We need to figure out the RMS value, we need to figure out. So therefore here basically the flux nature, the flux will be always sinusoidal in nature. So therefore phi is equal to phi m sin omega t. So therefore here always by using the Faraday's law, the amount of EM induced is N2 into d phi by dt, means the amount of range of total flux in the winding, which is N2 into d phi by dt. So therefore here now I am going to do the derivative of the flux. So therefore phi m into the sin omega t, means sin omega t will become cos omega t, and if you do the inside derivative again we are going to get omega. So therefore here E of t is equal to n to phi m omega cos omega t. So this is called as a peak value, and this is a cosine or sinusoidal in nature. So therefore the maximum value is n to phi m omega. But we need to find what is the RMS value, because for a sinusoidal nature the RMS value is peak value by the root 2. So therefore peak value is n to phi m omega by root 2. So in place of omega I am going to replace omega by 2 pi f. So therefore 2 pi f into n to phi m by root 2. So 2 by root 2 is again root 2. So root 2 5 pi f n to phi m. So therefore root 2 into pi, if you do the multiplication, we are going to get 4.44 n to f phi m. So therefore this is the RMS value. So therefore now RMS is equal to 4.44 n to f phi m. So we know the value of n2, which is 55, f is 50 hertz, and phi m is 0.02 webers. So finally if you substitute all those values, and finally if you do the multiplication of this one, we are going to get 244.2 volt is the correct solution of this question. And one thing you have to remember here, for the RMS value of the primary, if they ask what is the RMS value of the primary, here we can say here like this, which is same formula here, 4.44, just in place of n2 replace n2 by n1, so 5 fm. And similarly ERMS of the secondary, which is equal to, just in place of n1 replace n1 by n2, so remaining everything is same, 4.44 n2 5 fm. So always ERMS, so ERMS 1 by n1 is equal to ERMS 2 by n2, because here we can conclude that here the amount of EMF which is induced per single turn is same in both the windings. It means this ratio indicates that the amount of EMF which is induced in single turn, in one turn, is same in primary as well as in secondary. So therefore in a one turn, how much amount of EMF which is induced in the primary is equal to the amount of EMF which is induced in the one turn in the secondary. Both are same. This is an extra point here. So finally the solution is 244.2 volt is the correct solution of this question. So now we are going to solve the 23rd question. See the question here. The value of the integration theta is equal to 0 to pi by 6 cos 3 theta whole to the power of 4 sin 6 theta whole to the power of cube d theta we need to figure out. So what are the four options? 1 by 15 is the correct solution of this question. So let's solve this numerical. So the integration theta is equal to 0 to theta is equal to pi by 6 cos 3 theta whole to the power of 4 sin 6 theta whole to the power of cube into d theta, we need to find this integration. So basically what I am trying to say is, now I am going to assume 3 theta is equal to x. 3 theta is equal to x means I want to convert theta in terms of x here. So therefore 3 theta is equal to x here. So now I am going to do the derivative with respect to x. So therefore 3 into d theta by dx is equal to 1. So 3 theta is equal to, this dx is going to go to the right side, which is dx. So d theta is equal to dx by 3. So I want to convert all this theta in terms of the x. So therefore here, when theta is equal to 0, what is the value of x I need to know. So therefore 3 into 0 is equal to x. So x is equal to 0. So x is equal to 0. So if theta is equal to pi by 6, then I need to know what is the value of the x. So in place of theta, substitute here. 3 into pi by 6 is nothing but pi by 2. So therefore when theta is equal to pi by 6, the value of the x is pi by 2. So therefore here this x is equal to pi by 2. So here in place of 3 theta, substitute x. So cos x whole to the power of 4, and this we can write here 6 theta, we can write here 2 into 3 theta. So therefore 3 theta is equal to x, so 2x. So 6 theta can be replaced by 2x. So 2x whole cube, and d theta is equal to dx by 3. So therefore in place of d theta, dx by 3. So finally I have converted the theta in terms of the x. So therefore here this is the integration with respect to x now. So this 1 by 3 is a constant, so I am going to take it to the left side, which is 1 by 3. Integration x is equal to 0 to x is equal to pi by 2. See here cos x whole to the power of 4. Here sin 2x whole cube. So therefore sin 2x is equal to 2 sin x cos x. So 2 sin x cos x whole cube into dx. So here this 2 to the power of cube is nothing but 8. So I am going to make it to the left side out of the integration. So therefore 8 by 3. And the remaining terms are x is equal to 0 to pi by 2. See this sin x, if you do the cube, it is going to get sin x cube. And here cos x whole cube and cos x whole to the power of 4. So 4 plus 3 is 7. So cos x to the power of 7 dx. So finally we have to do the integration, means for this value we have to figure out. So basic formula is here. If integration theta is equal to 0 to pi by 2 sin x whole to the power of m cos x whole to the power of n dx. So if it is like this, the formula is here. Finally, here m minus 1 you have to take here, and then m minus 3 up to 1. See, you have to do the multiplication up to 1 you have to get here. And similarly here, if whatever the value of n, you have to go for the n minus 1, then n minus 3. So you have to continuously do the multiplication up to the value we are going to get 1. And in the denominator, we have to go for the m plus n. And then m plus n minus 2, so we have to do the multiplication up to, we are going to get the value of 1. And here into pi by 2, so here we have to do the multiplication of pi by 2 only if m and n are the even values. So the only condition is here, if m and n are even values, then only we have to multiply pi by 2, otherwise we don't have to multiply pi by 2. It is a special condition here. If anyone is not even, even if any m or n, even if any one of these both are odd, then we don't have to multiply by pi by 2. So the special condition is here, if m and n are purely even numbers, then only we have to multiply pi by 2 for this value. So therefore here, now this is the integration. For this integration, we need to figure out what is the value. So it's a constant. So therefore, same thing here, constant. So now this we have to figure out. So therefore here m is equal to now 3. So therefore here 3 minus 1, which is 2. And the next number is 1. So we can't have to write here because it is 3 minus 3 is 0. 0 also we must not write. Only up to value of 1 we have to take care. And now for this 7th one. So 7 minus 1 is 6. Into, so therefore after 6 the value is 5. 5 we must not write. The next value you have to go for the 4. And then after 4 it is 3. So 3 we must not write. The remaining value is 2. So therefore here 2. And then here 2, after 2 it is 1. So we must not write 1. And then 0 also we must not write, because up to 1 only we have to go for this one. And now in the denominator m plus n. So therefore 3 plus 7 is 10. After 10, 8. And then after means one number you must not write here in the between them. So after that again 6, again 4, again 2. So up to 2 means we must not write 0, because up to 1, either 1 is the last number. So therefore into 2 here. But now we have to check whether we must multiply pi by 2 or not. If you see carefully, 3 and 7 are odd numbers, so therefore we must not multiply pi by 2. So only this is the thing here. So now if you do the simplification, finally we are going to get which is 1 by 15. So therefore we can conclude that 1 by 15 is the correct solution of this question. See here, finally what I am trying to say is simply this formula is here. Whatever the value, one number you have to less it and you have to keep it here. Same thing here also. So 1 is 6. So after that one number you must leave, the remaining number you have to go for this one. So here 3 plus 7, 10. So one number you must leave and you have to go for the another number. Same process you have to repeat until you get 1, until you get the value of the 1 only. So therefore this is the value, and you have to go for the multiplication of pi by 2 only when both m and n are even, otherwise you must not have to take this value pi by 2. So finally, if you do the simplification for this, we are going to get 1 by 15. This is the correct solution of this question. So now we are going to solve the 24th question. See the question here. So what is the maximum bitrate of a noiseless channel with a bandwidth of 1000 Hz transmitting a signal with 2 signal levels? So in this question they are given a noiseless channel with a bandwidth of 1000 Hz and this signal is going to have 2 levels. So from this data we have to find what is the maximum bitrate possible. So what are the 4 options? Option A, 2000 bits per second is the correct solution of this question. So let's solve this numerical. So in the question they are given that the bandwidth is equal to 1000 Hz, means the message signal maximum frequency allowed is only 1000 Hz, not more than that. So therefore the maximum message signal frequency is only up to 1000 Hz. So therefore here in the question they also given that the number of signal levels are 2, means L is equal to 2. So always here the number of levels will always less than or equal to the power of n, means with the n bits we can make a number of levels are up to maximum value to the power of n. So in the question they are given the number of levels is 2. So 2 less than or equal to the power of n, and if you compare both of them, here we can write 2 by to the power of 1. So therefore by comparing them we are going to get the value of n is equal to 1 bit, means with the help of 1 bit we can make it 2 levels, means suppose 0 and 1. So with the help of 1 bit, suppose if you want the number of bits are 2, means 0 0 0 1 1 0 1 1. So level 1, level 2, level 3, level 4. So therefore now with the help of 1 bit we can make 2 levels, and with the bit of number of 2, with the number of bits 2 we can make 4 levels. So same goes on. If n is equal to 3 means we can make up to the number of levels are 8. So therefore maximum levels. So therefore here the sampling frequency always greater than or equal to twice the message signal maximum frequency. Suppose if it is less than this means there will be a aliasing effect, means the lower frequencies will become higher frequencies and higher frequencies will become lower frequencies. So therefore here the minimum message signal frequency means the minimum sampling frequency is or Nyquist frequency is twice the message signal maximum frequency. So 2 into the value of FM max we know, which is 1000. So therefore here 2000 hertz. So therefore now I want to know what is the value of the bit rate. Bit rate means the number of bits per second, how many bits are being transferred, that we need to figure out. So bit rate is equal to n into fs. So the value of unit of n is number of bits per sample, means the value of n is bits per sample. So for each and every sample how many bits we are going to take here, and the unit of the fs means fs is a sampling frequency, it is means the number of samples per second. So therefore if you do the multiplication here, the sample gets cancelled, so therefore bits per second is the unit of the bit rate, means the number of bits are being transferred in 1 second, how many bits are transferred, it is called as a bit rate. So n into fs, we know the value of n which is 1 and fs is 2000. So if you do the multiplication final, we are going to get 2000 bits per second, means in 1 second 2000 bits are being transferred by this circuit. So therefore the correct solution is 2000 bits per second is the correct solution of this question. So now we are going to solve the 25th question. See the question here. A signal has 8 data levels. So with a pulse duration of 1 millisecond, so what is the bit rate? So in the question they are given that 8 data levels are there with a pulse duration of 1 millisecond. So we have to find what is the bit rate. So from these two data we have to find what is the value of the bit rate. So what are the four options? Option C, 3000 bits per second is the correct solution of this question. So let's solve this numerical. So in the question they are given that the number of levels is 8 and the pulse duration is Ts. So therefore Ts is equal to 1 millisecond. It is a time between the pulses, the train of pulses, which is 1 millisecond. So therefore the sampling frequency is equal to 1 by Ts. So it is nothing but 1 kilohertz or 1000 hertz. So therefore here also they are given that the levels is equal to 8, means the number of levels always less than or equal to the power of n. So therefore L is 8 and less than or equal to the power of n. So I want to know what is the value of n. So 8 I can replace with 2 cube. So therefore by comparing we can get n is equal to 3. So therefore with the help of these two data we can find what is the bit rate, means the number of bits which are transferred in 1 second, which is n into fs. The unit of n is the number of bits per sample, and here the unit of fs, which is number of samples per second, or we can say the sampling frequency is the number of samples per second, means in 1 second how many samples are being transferred. So therefore here this sample gets cancelled, so therefore the unit of the bit rate is bits per second, means in 1 second this many number of bits are being transferred. So in place of n it is 3 and fs is 1000 hertz. So if you do the multiplication we are going to get 3000 bits per second is the correct solution of this question, means in 1 second 3000 bits are being transferred by this circuit or transmitter. So therefore bit rate is equal to 3000 bits per second is the correct solution of this question. So now we are going to solve the 26th question. See the question here. If a force F bar is equal to 2x square y I cap plus 3xy j cap displaces a particle in the xy plane from 0, 0 to 1, 4 along a curve y is equal to 4x square. So what is the work done? We need to figure out. So basically there is a force, the force expressions also they are given, and also we are going to move the particle along a curve. The curve path is y is equal to 4x square. So now we have to find how much amount of work we have to do if you are going to displace the particle from 0, 0 position to 1, 4 position along the curve y is equal to 4x square. We need to figure out how much amount of work is done. So what are the four options? Option C, 104 by 5 units of work has been done. So let's solve this numerical. So this is a graph here, y is equal to 4x square. So the initial point is 0, 0 and the final point is 1, 4. So basically there is a small particle. So this particle I am going to move along this path, y is equal to x square. So there is a force which is going to act on this particle, which is F bar is equal to 2x square y I cap plus 3xy j cap. So with the help of this force along this particle, so how much amount of work is done in order to move this particle from initial position to final position, we need to figure out. So basically here which is, see, the small amount of distance. So I want to find what is the small amount of distance, which is dx I cap plus dy j cap. Means a small amount of in the x direction is dx, and in the y direction is which is dy. So therefore the small amount of distance in that line, which is ds bar, is equal to dx I cap plus dy j cap. So I want to know what is the value of work. So work is equal to the dot product of the force and the displacement. So therefore the dot product of the force and the displacement, here this is the path, right? So therefore over this line integral, so over this path we have to do the integration. Means we have to add each and every force is, so we have to add each and every dot product along the total length we need to figure out. So therefore this integration is nothing but it's an addition of small amount of individual works. So therefore is the integration. So here now you have to go for the dot product of these two things. So by using the dot product principle, only and I cap are going to get multiplied. So therefore 2x square y dx plus 3xy dy. By using the dot product we are going to get this expression. So now here this expression has x variable and y variable. So I want to convert this into only one variable, whether y or x. So I am going to prefer to convert all this in terms of x variable. I want to convert here. So therefore here y is equal to 4x square. So I want to do the derivative with respect to x. So dy by dx is equal to 8x. So I want to know what is the only dy. So dy is equal to 8x dx. So I want to convert this whole expression of two variables into only one variable. So therefore here I want to convert only in terms of x. So wherever y is there, so we have to convert that into in terms of x. So therefore here there is a y. So y is nothing but 4x square. So in place of y substitute 4x square, and here y means 4x square. But here dy is equal to 8x dx. So therefore here that I have substituted here. So y is 4x square, and dy is 8x dx. So now finally here, if you do the simplification of this one, we are going to get 8x to the power of 4 dx, and if you do the simplification of this, we are going to get 96x to the power of 4 dx, and these both the terms are same. So therefore if you add them, we are going to get 8 plus 96, which is 104 x to the power of 4 dx. So here finally this integration is now only in one variable x. So if you see carefully here, the initial x is 0 and the final x is only 1. X coordinate, I am going to take only the x coordinate. So initial x coordinate is 0 and the final x coordinate is 1. So therefore here the total integration with respect to x, so therefore initial x position is 0 and the final x position is 1. So therefore now here 104 x to the power of 4 integration is x to the power of 5 by 5. The lower limit is x is equal to 0 and the upper limit is x is equal to 1. So after solving this one, we are going to get 104 by 5 is this much amount of work is to be done if you want to transfer the particle from 0, 0 to 1, 4 along the path y is equal to 4x square. And this is the correct solution of this question. So now we are going to solve the 27th question. See the question here. Three cities A, B and C are equidistant from each other. One motorist travels from A to B at 20 km per hour and from B to C at 40 km per hour and C to A at 50 km per hour. So what is the average speed we need to figure out? So here out of the four options, option D 34.6 km per hour is the correct solution of this question. So let's solve this numerical. So basically there are three cities A, B and C. The distance between them is same, which is D and D I am going to assume. So there is one motorist is going to travel from city A to B with a speed of 20 km per hour, and from city B to C is going to travel with a speed of 40 km per hour, and from city C to city A he is going to travel with a speed of 50 km per hour. So in this total journey we want to find what is the average speed. So average speed is equal to total distance by total time. Suppose if in this question if they ask what is the average velocity, so average velocity is total displacement by total time. See, the total displacement is 0 because whatever the initial position is equal to final position, so therefore the total displacement is 0. So in that way, if they ask what is the average velocity, the answer is 0 because the total displacement is 0 because the initial position is equal to final position. So therefore here, but in this question they ask what is the average speed. So average speed is nothing but it is a scalar quantity. So therefore total distance by total time. The total distance of the journey is, this is the journey D from city A to city B, which is D, and city B to city C, which is D, and from city C to city A, which is D plus D, 2D. So this is the total distance covered by the motorist. So I want to know what is the total time. So therefore time, so time for traveling from A to B, and time for traveling from B to C, and finally time for traveling from C to A. So I want to know what is the time from A to B, which is distance is equal to speed into time. So time is equal to distance by speed. So distance d by speed is 20. So distance d by speed is 20 km per hour. And I want to know what is the time from city B to city C. So time is equal to distance by speed. The distance is d and the speed is 40 km per hour. So therefore distance by 40 km per hour. Plus again from C to A, the distance, total distance is 2d and the speed is 50. So distance by speed, which is 2d by 50. So 2d by 50. So total time is you have to add for each and everything. So if you do a simplification, finally we are going to get the average speed is 34.7 km per hour. This is the correct solution of this question. Now we are going to solve the 28th question. See the question here. The ramp response for a system whose transfer function g of s is equal to s by s plus 4 into s plus 4, s plus 8. So there is a transfer function for the system. If the input is a ramp input, so we have to find what is the ramp response. So what is the response of this ramp input, we need to figure out. So what are the four options? The expression c of t is equal to, option C is the correct solution of this question. So let's solve this numerical. So this is a transfer function box. So for this input is r of t and the output is c of t. So here input is ramp input, means r of t is equal to t into u of t. So if I want to know what is the Laplace domain, which is r of h is equal to 1 by s square, means for t to the power of n, the Laplace domain is, the Laplace transform is n factorial by s to the power of n plus 1. So here n is equal to 1. So 1 factorial by s to the power of 1 plus 1, which is 1 by s square. And the g of s, the transfer function box is s by s plus 4 into s plus 8. So now I want to know what is the time domain expressions for this response we need to figure out. So therefore here always the transfer function is equal to output by input Laplace domain. So therefore c of s by r of s is equal to g of s. So c of s is equal to r of s into g of s. So r of s value, which is 1 by s square, and g of s value I have substitute. So finally here 1 by s square, here s is going to get cancelled. So therefore finally here I am going to get, this is the expression. So 1 by here. So final expression is 1 by s into s plus 4 into s plus 8. So I want to go for the partial fractions. So therefore here the denominator is s plus 4 and s plus 8. So I want to know what is the coefficient for each and every term I need to figure out. So here if s is equal to 0, because it is s minus 0, so therefore I can take s is equal to 0 and substitute in the remaining values, which is 1 by 0 plus 4 is 4 and 0 plus 8 is 8. So 1 by 4 into 8, which is 32. So this is the coefficient 1 by 32. And similarly here s plus 4 is equal to 0. So therefore s is equal to minus 4. So s is equal to minus 4, you have to substitute in the remaining terms except s plus 4. The remaining terms you have to substitute. S is equal to minus 4. So this is minus 4 into minus 4 plus 8, which is 4. So 1 by minus 4 into 4 is nothing but minus 1 by 16. This is the coefficient here. And similarly s plus 8. So for this coefficient we have to find, which is, so s plus 8 is equal to 0 means s is equal to minus 8. So substitute s is equal to minus 8 in the remaining two terms except s plus 8. So which is 1 by, so here in place of s substitute minus 8. So therefore minus 8 into, here s plus 4 means minus 8 plus 4, which is minus 4. So 1 by minus 8 into minus 4, which is 1 by 32 plus 32. So this is a partial fraction method. So same thing I have written here. C of s is equal to same expression I have written, same thing here. So now I want to know what is a Laplace inverse domain, means time domain expression I need to figure out. So here Laplace inverse of 1 by s, which is 1. So here 1 by 32, and here e to the power of 80. The Laplace for domain is 1 by s minus a. So 1 by 32, this is minus 1 by 16 into, it is e to the power of minus 40, and 1 by 32 coefficient into 1 by s plus 8, which is e to the power of minus 80. So by using this formula. So if you want e to the power of minus 80 means it is 1 by s plus a. So same formula. So therefore here this is the time domain expression. So now we are going to solve the 29th question. See the question here. So what is the value of the shunt resistance of an ammeter if the range is extended from 1 milliampere to 10 milliampere and the meter has a resistance of 27 ohm. So basically the meter is going to have a resistance of 27 ohm, and also we are going to extend the current of this meter from 1 milliampere to 10 milliampere. So what is the shunt resistance required, that we need to figure out. So what are the four options? Option A, 3 ohm is the correct solution of this question. So let's solve this numerical. So basically this is a PMMC circuit here. This RM is the meter resistance and IM is the meter current. And here this is a RSH. In shunt resistance we are going to keep in order to remove or in order to flow the excess current through this RSH. So therefore here in the initial the IM is equal to 1 milliampere. So you want to extend the range from 1 milliampere to 10 milliampere. So therefore you have to keep an extra shunt resistance, means in order to make the remaining current to flow this to flow through this shunt resistance instead of the RM. So therefore here I is called as circuit current and IM is called as a meter current. So therefore in the question they are given the IM is equal to 1 milliampere and I is equal to 10 milliampere. Means we are going to extend the range from 1 milliampere to 10 milliampere, and the value of the meter resistance means RM is equal to 27 ohm. So we have to find what is the value of the RSH we need to figure out. So basically if you see carefully at this junction, by using the KCL, the sum of incoming currents is equal to sum of outgoing currents. The incoming current is only I and the outgoing currents are IM and ISH. So therefore I is equal to IM plus ISH. So I want to know what is the value of ISH. So therefore I minus IM is called as the ISH. The value of I is 10 and the value of IM is 1. So 10 minus 1 is 9 milliampere. So the value of the shunt current is equal to 9 milliampere. So here the voltage across both of them are equal because they are connected in the parallel. So therefore the voltage across them is same. So the voltage expression is equal to current into resistance. So therefore IM into RM is equal to ISH into RSH. So I want to know what is the value of RSH. So therefore RSH is equal to IM RM by ISH. So the value of IM is 1 and the value of RM is 27 and the value of ISH is equal to 9. So therefore if you do this one, 9 3s are. So therefore RSH is equal to 3 ohm. So therefore we can conclude that RSH is equal to 3 ohm. So you can do it in another fashion also directly by using the formula RSH is equal to RM by M minus 1, where M is called as a I by IM. So I is called as a circuit current and IM is called as a meter current. So with the value of I is 10 by 1, which is 10. So therefore RM is equal to 27 by 10 minus 1, which is 27 by 9, which is 3. So you can go directly by the formula also, which is 3 ohm, or if you forgot the formula you can go by this procedure also. So now we are going to solve the last question of this lecture. See the question here. A voltmeter has a resistance of 20 kilo ohm and connected in series with an external resistance across a 230 volt supply. If the instrument reads 160 volt, then the value of the external resistance is we need to figure out. So basically here they are given a source of 230 volt and the voltage across the instrument which is 160 volt. So we have to find what is the value of the external resistance we need to figure out. So what are the four options? Option C 8750 ohm is the correct solution of this question. So let's solve this numerical. So in this question they are given a voltmeter of resistance 20 kilo ohm. So here they want to read 230 volts. So therefore they are going to apply an external resistance in series with this meter. So this is our external resistance. So here to measure this 230 volt, the voltmeter is going to measure the 160 volt. So therefore the remaining voltage means 230 minus 160 is nothing but 70 voltage is going to drop across the external resistance. So therefore the meter is going to actually measure the voltage of 160 and the out of 230 the remaining voltage 230 minus 160, the 70 voltage is going to drop across the external resistance. So we have to find what is the value of this external resistance we are going to figure out. So basically if you see it is a series circuit, so therefore current is equal to same. So whatever the current in this resistor is equal to current in this resistor. So current is equal to voltage by resistance. So therefore the voltage of this current in this circuit in this resistor is equal to 160 by 20 kilo ohm. So 20 into 10 to the power of 3 and the current in this resistor is equal to voltage by R external. So voltage by 70 by R external. So current is same because it is series circuit. So there is only one equation with only one unknown. If you solve this one we are going to get 8750 ohm. Or you can do it in another fashion if you remember the formula which is R external is equal to RM into M minus 1. It's a series fashion. So therefore the value of RM is equal to 20 kilo ohm, the meter resistance, and M is equal to total voltage by voltage measured by the meter. The total voltage is 230 and the voltage which is measured by the meter is 160. So by this also you can do, you can substitute the value of RM substitute and the value of M also we can substitute. Then if you do the simplification, finally the same answer we are going to get 8750 ohm. So in both the methods you can get the same result. So by this lecture we have successfully completed the 30 questions which are the questions of the ESE 2021 of electrical engineering of prelims in a very detailed manner. And if you like the content of our channel then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button so whenever we upload a new video the direct notifications comes to mobile. If any improvements needed in our lectures then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.